Hi, I'm Joshua and now I'm going to start my presentation of our project, which is Smart Parking Management System. So here you can see the table of the content, which have introduction, the system overview objective, database design, then the core functionality, and also implementation strategy and conclusion. So now is my part, which is the introduction. So Smart Parking Management System, SPMS, is a comprehensive solution designed to digitize and optimize parking operations, leveraging real-time data, automation, and user-centric design. So we got four key components, which is user management. So you can register and manage regular or occasional parkers. Then next is the parking slot and slot tracking. So we'll monitor every parking slot in real time. Then booking and session management. So handle the entry life cycle of a parking session from entry to exit. Then the last one is the payment processing. So we'll facilitate seamless and secure digital payments. So here is our objective. We got also three objectives. The first one is real-time occupancy tracking. So we're trying to develop a database system that tracks the real-time status of every parking slot. So will enable us to guide the user to the available parking space efficiency and also reduce the congestion. Then next one is to centralize the data and analytics. So implements a robust database that aggregates the historical booking and payment data, will empower the management of with the actionable insight through analytical reports for strategy planning. Then the last one is automate billing and payment. So the utilize SQL function and trigger can help to automate the fee calculation and also payment tracking. So we'll ensure the high data integrity, faster transaction, and also eliminate the revalue linkage. Then next is the system architecture overview. So also have three. The first one is user layer, which is the front-facing layer for user to integration, including mobile apps, web portal, and also physical kiosk. The next part is the application layer. This is the system brand which handling the core service like user parking, booking, and also payment management. Then the last one is the data layer, which the foundation using a relational database for transaction and a data warehouse for analytics. So here is all of the part that I present. Thank you.
Good day, my name is Victor Chow Jing Kai. Now, let's dive into database design. This entity relationship diagram illustrates the core entities of our system: users, parking lot, and booking, and payment. These relationships between them are crucial. For example, one user can have only many bookings, and each booking is associated with one parking slot. This structure ensures data integrity and efficient querying. Each entity has a well-defined set of attributes. The users table stores personal and vehicle details. Parking lots and parking slots track the physical spaces. The bookings table records each parking session, and the payment table handles all financial transactions. Foreign keys, like lot ID in parking slot, ensure referential integrity across the database. We have applied the principle of database normalization up to 3NF. This process involves organizing data to reduce redundancy and improve data integrity. By doing so, we ensure that our database is efficient, scalable, and less prone to errors. Each table serves a single purpose, and relationships are clearly defined. Let's look at how we implement core functionalities using this database. For user management, we handle registration, authentication, and profile update. Here's a simplified SQL query that demonstrates how we might authenticate a user using a secure password hashing function to protect sensitive data. For parking and slot management, real-time data is key. We use database triggers automate updates. For instance, when a booking is made, this trigger immediately marks the corresponding parking slot as occupied. This ensures that our availability data is always accurate and up to date. Booking management involves handling the entire life cycle of a parking session. We use stored procedures to encapsulate this logic. For example, this stored procedure checks if a slot is available before creating a booking. If it's available, it creates the booking, otherwise, it throws an error. This ensures data consistency and enforces business rules at the database level. Payment processing is another critical area. We have created a function that calculates the parking fee by considering the duration of the stay, the applicable rate for that parking lot, and any membership discount. This function is then used to generate a payment record, ensuring accurate and automated billing.
Okay, hi everyone, my name is Kosun Jin. Today I would like to present about our demonstration part for our system. So let me log in the Maria database. Right now. So I don't set a password, so can straight to enter and then use our database. I set as this name. Cool. Okay. So let's start our demonstration part. So at the first, we got a user table. Select from user table. So you can see we already got a 4 user inside the table because I need to demo to run the system first. So we can add the new user inside this. Okay. So I set the name as a Victor and the membership type as a standard. So he will got a 10% discount for our system. Okay, so let's say yeah, we already successfully add inside. Okay, so next is our parking lot. So we already got 2 parking lot inside here. So MMU north screen, MMU south screen. And now we can add or create a new parking lot with this command. So it's successfully inside it. Okay. Yeah. You can see it, we already successfully insert it. So we got a 3 parking lot now. Then after this, uh, we also got a parking slot for every parking lot. So we got 5 parking slot now. All is available. This is we got a trigger to each slot ID. So if a booking is a user to try to book, and we got a trigger to prevent double booking. So after I'll show you. So now if I want to add a new column for our parking table, parking slot table, as like this. So you will see the parking slot table will add a new column to the right side. Of course, we don't need to use, so we also can update or delete it, can drop it. Okay, so let's see we draw or not. Yeah, already draw it. And then after the next table is not the next table is we need to insert a new parking slot ID to try to run to prove it can use this table. So okay, so we insert a new slot ID because this slot ID is under the parking slot, which is the MMU West Wing. So I'll show you the parking slot is here. Yeah, already successfully inserted. So it's under the lot ID number 3, and then the slot number is 301. Available now. Okay. So I'll show you the next table is the booking. So we already got a 2 booking ID in here, already successfully run. So insert a new booking ID in here. Okay, successfully insert. Because this number 5 is the user number 5, which is our added just now, the Victor. Then the number 2 is the slot ID, which one you want to book the slot. And then the time, yeah, the morning the time, and then the sensor is active now. So he just enter. Yeah, he haven't exit, so the sensor is active. And then after, if he already, oh no, Also, we can see the parking slot now. You can see the parking slot, the ID number 2, because he already booked, so the trigger will function now. So the system will detect the car is inside the parking slot now. So of course he cannot double booking now. I'll show you. Okay, so see the user number 4, then see what happened. So you'll show the error. The error message, this slot is already currently occupied by another car. So we can, to prevent the double booking. Okay, so you also won't have the new user inside the booking. Okay, so now we can update the booking if you want to exit. The user exit now. Okay, so let's see. So he already exit now. The morning he entered the time, the morning 8 o'clock, and then until the 4 o'clock PM. So this is already completed. After the completed, you can see the parking slot and okay, cool. So you can see the slot ID number 2 is available now. Because I add a new trigger is to detect when the user, the booking ID user, when they exit and the setter is completed. So you will release the slot ID to 0 to 1. So you can book a new user now. Allow the new user to book now. So go back. And then after the user exit, of course he need to make the new payment. Okay, the payment table already got 2. So we can add the new payment, insert it for the user just now to exit. Then let's see what got. Yeah, so 1 hour is fine, I guess so. Because he is a standard user, so he will got 10% discount. So the payment status is pending now. So after you pay, or I will receive the payment successfully, so we can update the status to pay. So let's see. Yeah, already paid. Okay. So actually we already done the demonstration part.
Good day everyone, I'm Liu Chao from Database Lab Section 1B. Our database design efforts several key business rules. These rules ensure the integrity of our data and the correct operation of the system. For example, a slot can be double booked and each booking must have a corresponding payment. These rules are embedded in the SIMR design triggers and store procedure we will discuss that. The SPMS caters to a diverse set of our users. Each will unliquid need individual driver when they want to convert operator seek for efficiency and revenue through commercial and entities need integration and government aim to reduce congestion. Our database design is flexible enough to meet all these requirements. SWOT analysis helps us understand our position. Our strength lies in our robust technical designer. Our weakness include dependency on external infrastructure. The opportunities are vast, and especially with AI integration, and we must be vigilant about this like data security and competition. In conclusion, we have successfully designed a robust and scalable database for the smart parking management system. The 3NF compliant, scalable, and automated process ensure that the system is efficient, reliable, and ready to deliver scientific value to user, operator, and city alike. Thank you for your time. I'm happy to answer any question you may have about the database design or the smart parking management system.